without further ado, in corner one, we have John the Regulator DeLong, hailing from all the way from Seattle, Washington. He builds little robots that drive around the house and confuse his cat. Standing at 6'4" tall, don't be confused. He is both terrible at basketball and mini golf, so the height's not helping in any way. And his favorite superhero is Spider-Man. Let's welcome John the Regulator DeLong. Let's have some excitement for John here in the chat. And in the other corner, he is going to be facing off against Will, the Traveler Eger. Will is more local. He's hailing from Middletown, New York. But that doesn't mean he's not going to be fierce competition. He is a master of many modes of transportation, from running all the way to skiing. But he can be found merely floating around in the water. And Will beat cancer, and he can beat you too. So, John, this is not going to be an easy fight. Let's give it up for Will, the Traveler Eger. Can I have some excitement for Will in the chat? Okay, so, all right, everyone. I'm going to need this to be a clean fight. But before we begin, do you have anything to say to each other?
I just wanted to say, Will, I hope you're vaccinated because this presentation is going viral.
Ooh, that's tough. Okay, Will, anything to say about that?
All right, John. I know some of us have to go outside of the lab, but, not everyone has that. So good luck and get out there.
Okay. He's showing off all of his modes of transportation. He's going global. All right, so to see who's going to begin, we are going to start with a coin toss. Eli, please bring up the coin.
All right. Do we have, let's see, William, your video's on, so you're gonna call the coin. When I hit flip, I'll count it down, and then you give me a heads or tails. Ready? 3, 2, 1.
Tails.
All right, man.
Oh.
Going.
All righty. Hi, everyone. My name is Will Eger, and I'm from the Yale School of Public Health. And today I'll be presenting to you about my research on the social and everyday influences on health and how that impacts COVID-19 vaccination. Before we get started, I'd love for you to grab a piece of paper and a pen or pencil. We'll use this so you can show me your answers to my questions throughout the talk to help you stay engaged. And you have 30 seconds. Go. Another way to do this is you can share through the chat. So if you don't have a pen or a pencil, that's okay too. In the meantime, I wanted to share with you how I got started as a scientist. It all started where I grew up in Orange County, New York, just 2 hours away from here. My first involvement with science was as a childhood cancer survivor, which changed my life forever. My diagnosis and treatment made it so I was at the hospital all the time, but this really allowed me to be immersed in science and the people working to save my life. As I grew older, I wanted to be the type of person that would help families like mine recover from health problems. Therefore, when I went to college, I traveled around the world working on projects in communities that would solve pressing health issues like healthcare and access. For example, you can see me here riding a mule up an inactive volcano in Ecuador and posing with Usain Bolt in Jamaica. Although traveling around the world doing science was amazing, it made me reflect on all of the problems here at home, especially considering the COVID-19 pandemic. I wanted to use science to help solve the issues that are impacting our communities right here in the United States, which we'll be focusing in my talk today. So, the COVID-19 pandemic has really impacted us all and transformed our lives over the past year. It all started off scary, but really ironic too. Like you see here with Smeagol hoarding toilet paper like he would the ring from Lord of the Rings. Then, I bet all were as excited as me to have an extra long spring break, like Oprah handing out gift baggies on her show. Meanwhile, over the summer, we were all starting to see the terrible effects of COVID-19 on our social life and health. This is really when I started asking, can I please cancel this subscription now? And now we're at the point of asking ourselves, when will this all be over? Well, I'm going to help you answer that question today. But first, I wanted to see how COVID-19 has impacted your life. If you feel comfortable sharing, how has the COVID-19 pandemic impacted your lives? Please feel free to share in the chat or on your piece of paper. And feel free to use the chat as well if you aren't able to use the video. Yes, some people miss their friends, teachers, they had to move, they lost motivation, and it just stopped from being able to go outside and doing things. Yeah, so clearly the COVID-19 has impacted us in a lot of different ways. So thank you all so much for sharing your thoughts and experiences. Before we dive deep into solving the COVID-19 crisis, I wanted to give you a brief overview of COVID-19 and pandemics. COVID-19 is an illness caused by a virus called SARS-CoV-2, which stands for Severe Acute Respiratory Syndrome Coronavirus 2, and it looks like this. Coronavirus actually gets its name from the Latin word corona, which means crown, because of how the spikes on the outside of the virus resemble a crown when looking under a microscope. On the other hand, as you've been seeing in the bottom right-hand corner of your screen, a pandemic is the occurrence of a specific disease that impacts several countries or continents. And each of these red dots below represents the spread of COVID-19 as it jumped from country to country throughout the pandemic. So, as we mentioned before, the COVID-19 crisis has changed our lives in a lot of different ways. Well, the reality is that it changed everyone's lives in a lot of different ways. Many of our parents or friends have been working tirelessly to help stop the COVID-19 crisis. For example, doctors, nurses, and other healthcare workers help on the front line treating patients with COVID-19 so they can feel better and recover quickly. Basic scientists and engineers, on the other hand, like John, help develop medicines and therapies like vaccines to help prevent the spread of COVID-19. Politicians and policymakers create programs and guidelines which require masks or give people economic relief, like the COVID-19 stimulus checks. Public health officials and researchers, like myself, help politicians develop relevant health guidelines, do research on the spread of COVID-19, and help get medicines and vaccines to people in a safe and ethical manner. So, public health researchers play an important role in stopping the pandemic, and then we try to understand the health of different groups of people. Much like the characters in Among Us have different traits, like their color or hat design, people all over the country and world have different traits like their age, skin color, or nationality, which public health researchers try to study. Unlike Among Us, people's everyday traits affect them in different ways and can impact their health. Can you give an example of one type of group character trait public health researchers might be interested in studying? And please feel free to share in the chat. And again, that was just asking you for an example of one type of group character trait public health researchers might be interested in studying. Young people, age, religions, these are all great. Mental illness, that's another awesome one. Health, genetics, you all are right on it. So thank you for sharing, and you all had some really insightful responses. So the types of traits that public health researchers study are usually divided up into two large groups based on how they impact people's health: biology and lifestyle versus social and historical. Then within those two different groups, there are many smaller groups, such as health status, which is how healthy you are in general. Do you get sick a lot or have a certain health condition like asthma, which can be grouped as poor, good, or excellent. There are also groups like age and weight, or different types of diseases like COVID-19 or the flu, which might influence how fast illness spreads from person to person or how sick you might get. Meanwhile, Examples of social and historical traits that influence health are things like education, income, location or where you live, or race and ethnicity, which we will talk a lot about today. Before moving forward, I wanted to clarify the definitions of race and ethnicity and talk about why they're important to study in public health. Race is the grouping of people based on shared physical or social qualities generally shaped by society, whereas ethnicity refers to a group of people that share a common set of traditions, ancestry, language, or culture. The most common races in the United States are white, Black or African American, and Asian, and the most common ethnicities are European and Hispanic. However, as you can see on the bottom here, race and ethnicity can overlap where someone can be both white and Hispanic. So race and ethnicity play an important role in the United States because they often determine someone's background, where they grew up, and how society sees them. Historical policy decisions, meanwhile, like the ability to vote or where certain groups of people could live, has shaped the health of people from certain racial and ethnic groups. Therefore, the reason that race and ethnicity are social and historical influence on our health is largely due to our country's history with racism, such as slavery or the detainment of asylum seekers at the Mexico border. But I want to be absolutely clear that this is not just a historical problem and that racism still contributes to unequal treatment of many groups and is something we all need to actively fight against. One way I'm hoping to fight against racism and unfairness is to research the social influence on health and to learn ways in which we can make everyone healthier. So, although we talked about social and historical factors related to health, like income, location, or race and ethnicity, I also wanted to talk to you about negative everyday influences on health. Everyday influences on health are things about your life outside of medicines or healthcare visits that can affect your health. Meanwhile, examples of negative everyday influence on health are things like not having access to housing, not having the ability to pay your utility bills, and not having access to food. Due to social and historical reasons, Black or African American and Hispanic people experience these negative everyday influences on health about 2 times more often than non-white Hispanic people. The negative everyday influence on health are just one way certain social and historical traits change the health of different groups of people. The different groups people belong to, along with the negative everyday influence on health, have really impacted the COVID-19 pandemic. We now see that over 500,000 Americans have died because of the COVID-19 crisis, which is almost double the amount that died during World War II. Isn't that crazy? And however, the way people have died and been infected isn't equal among different groups. For example, Black or African American and Hispanic people are about 2 times more likely to be infected by COVID-19 than white Americans, which represents a social and historical trait. On the other hand, a biology and lifestyle trait that has impacted the pandemic is age, where 8 out of 10 COVID-19 deaths in the United States have been in adults 65 years and older. Hopefully, this slide helps you realize how important public health research is for studying issues in particular groups. While the COVID-19 pandemic has been really bad and sad for a lot of reasons, amazing scientists have been at work to stop the pandemic. Because of great scientists, there are amazing solutions to stopping the spread of COVID-19, like the development of the COVID-19 vaccine, which I just got this weekend. The COVID-19 vaccine helps prevent people from getting sick from coronavirus. The vaccine helps strengthen your immune system to fight off the virus before it can make you really sick. Wearing masks is another great way to help prevent the spread of COVID-19 by catching droplets released when you talk, cough, or sneeze. Actually, which is amazing, is that getting the COVID-19 vaccine or wearing masks can prevent 50 to 70% of COVID-19 cases from ever happening. But just because we have the vaccine does not mean everyone is going to take it. Currently, 3 in 10 Americans do not plan to get the COVID-19 vaccine. However, Specific groups are even less willing to get the vaccine. For example, 4 in 10 Black or African American people do not plan to get the COVID-19 vaccine. And although that might not seem like a big difference when you're asking only 10 people, let's say you asked 1,000 people or 10,000 people, that would be a difference of 100 or 1,000 people not getting the vaccine. As public health researchers, we needed to ask why. Why are different social groups, like those from different races or ethnicities, more or less likely to get the COVID-19 vaccine? We guessed that everyday influences of health might have something to do with it. To answer that question, my team and I developed a research plan. We started off with a goal to understand how the everyday influences of health and the experience of different groups of people affect someone's willingness to get the COVID-19 vaccine. Then, we had to make an educated guess as to what that answer might be. So, we guessed that the negative everyday influences on health play a role in making Black or African American and Hispanic community members less willing to vaccinate. From there, we needed to gather this information from community members. As a team, we developed a survey with a bunch of questions to ask people about their experiences during the COVID-19 pandemic. We were able to ask 252 people from a bunch of different biological and lifestyle or social and historical groups from all over Connecticut about their experiences with the COVID-19 pandemic. From our survey, we had 3 main conclusions. First of all, 4 in 10 adults within Connecticut are unlikely to take the COVID-19 vaccine, which is a little bit above the national average of people being unlikely to vaccinate, which I explained a little bit earlier. Secondly, people experiencing the negative everyday influences on health are less likely to vaccinate than people who do not experience the negative social influences on health. Lastly, African American and Hispanic community members were more likely to experience the negative everyday influences on health. Therefore, our survey confirmed our educated guess that the negative everyday influences on health were changing for the worse the way certain social groups were willing to vaccinate. So we need to talk about importance here. Why is this research important? And why is it important to ask research questions among diverse groups of people? Our background and experiences influence how healthy we are and the way we engage with healthcare. Due to historical and social reasons, it is important to recognize each other's differences and thoughts because we don't all experience life the same way and have the same privileges. Personalized and focused health prevention strategies, like vaccination campaigns, help us to become healthier because they identify our differences and use them to customize the care we receive. Before leaving you today, I wanted to provide you with some sources to get more information about the COVID-19 pandemic, COVID-19 vaccination, and the experiences different social groups are facing during this crisis. Please feel free to visit the Centers for Disease Control, Connecticut.gov, Yale New Haven Health, or the University of Connecticut website for more information. I would like to thank my research team for helping me put this slide deck together and their valuable feedback. I'd also like to thank my friends at the Yale School of Public Health for always supporting me. And ultimately, I would like to thank you all so much for listening to my talk today. Thank you.
Thank you so much, Will, for an amazing talk. We are now going to be hearing from your competitor, John, and see what he can share with us all today. So, John, if you would like to get your presentation ready, we're all super excited.
Okay. So, my name is John, and I am a biomedical researcher, and I also really like superhero movies. Let's see. This is a picture of my lab from the last Halloween before coronavirus. And what you can appreciate here, so there's me in the back dressed up like Thor. And you can see that I am not the only person in my lab who likes superheroes. So I wonder, what are some of your guys' favorite superhero movies? You can let me know in the chat. Spider-Man, Captain Marvel, Endgame, nice. Far From Home. Oh, one person doesn't watch superhero movies. Okay. Any DC fans? Any Wonder Woman? Okay. Excellent. Thanks for sharing. So one of my favorite superhero movies is Captain America: Civil War. This movie grapples with the problem that whenever superheroes save the world from some evil villain, they always end up doing a huge amount of damage. The superheroes end up doing a huge amount of damage to the people and to the cities that they were supposed to be defending. And so the movie asks the question of how can we maybe try to limit the power of these superheroes so that they don't cause so much damage while they're protecting us. And one of the reasons that I really like this movie is because it's actually related to the research that I do. So I research the question of how can your body set up a system that effectively defends yourself from invasion by bacteria and other germs, and is powerful enough to kill those germs and protect your body from them without killing your body's own cells. Similarly to how superheroes need to defend people and to defend cities without hurting the people who are in those cities. And I'll tell you about that today. So the system that I'm talking about is your immune system. Your immune system is what protects you from infection. And your immune system is composed of white blood cells, which are literally just white cells that are flowing in your blood, circulating through your body. And this here is a microscope image of blood that a scientist has put on the glass slide and just looked at under the microscope. And so what you can see here is that there are a few different types of cells. We have these round ones are all red blood cells. This little kind of smudge over here is a bacterium. And this giant cell in the middle is a white blood cell. So there are a lot of different kinds of white blood cells, and they have different functions in the body. They play different roles in protecting you from infection. But this one's a neutrophil, and it is specialized to find bacteria and chase them down and eat them and kill them. So in the context of superheroes, the white cell in the middle is a hero, like the Hulk. The bacterium is a villain, like Red Skull. And all of these other cells over here are the innocent bystanders. And so what we need is we need the Hulk to kill the villain without hurting the innocent bystanders. And we can actually watch that happen. So you can see here that as the bacteria struggles to get away, the neutrophil keeps following it. And it doesn't hurt these red blood cells. When the bacteria goes through the red blood cells, the neutrophil just pushes them aside and keeps chasing the bacterium until finally it catches the bacteria, eats it, and kills it. So this is happening all the time in your body. Whenever you get a cut on your finger and bacteria gets in the cut, neutrophils come out of your blood and they find that bacteria and they eat it up and they kill it. And then the neutrophils die because their job is done. They've done what they were supposed to do. And this is actually the reason that when you get an infected cut, you get white pus in the cut. You might think that the pus is bacteria, but that white pus that forms an infected cut is actually your own white blood cells. And it's these cells exactly. It's neutrophils that have gone into your cut and killed the bacteria and then died. So that's what happens when you're infected. But when you're not infected, your immune cells don't need to be killing anything. So when you're not infected, when you're healthy, when all your cells are healthy, your immune system is calm. It's just surveying your body, making sure that nothing is wrong. However, if you get infected, let's say with bacteria, and your cells are infected with that bacteria, your immune system needs to get activated so it can kill those germs and make you better. So in other words, Bruce Banner needs to turn into the Hulk, right? You need to turn into a killing machine so you can kill all those bacteria, and you also need to kill the infected cells. Because once a cell is infected with bacteria, the bacteria can divide in that cell and actually spread the infection to other cells. So I told you that there are many different types of white blood cells, and we already talked about neutrophils. Another type of white blood cell that's really important in the body is a macrophage. So macrophages, when you're healthy and when you're not infected, macrophages are just sitting in your body calmly, not killing anything. They're just surveying. But macrophages, like neutrophils, are really good at detecting bacteria and infection. And so if you get infected with anything, those macrophages will become activated macrophages. And so these are killing machines that will go around, they will kill the bacteria, and they will also eat up the infected cells that died to remove them from your body. And this is really important, right? This is important for helping protect us from infection. However, what you need to remember is that all of these infected cells in your body are surrounded by healthy cells. And it's important that these activated killing machine macrophages don't also kill the healthy cells when they, in the process of killing these infected cells. So your macrophages need a way of turning themselves off once an infection is cured and turning back into these non-activated macrophages so they don't actually damage your own body cells. In other words, we need a way of calming the Hulk down, turning him back into Bruce Banner so he doesn't keep Hulk smashing things after the villain is already killed. So far we've only talked about infection, and the immune system is really important for defending your body from infection. But the immune system is also important in other contexts in the absence of infection. In my research, I study a disease called stroke, and I study a particular form of stroke that happens when a blood vessel bursts in your brain. So of course your brain needs blood in order to function correctly, but that blood needs to be contained in blood vessels. And if a blood vessel bursts and then blood leaks out into the brain, that can cause brain damage and can be really severely damaging to a person. So I'll walk you through how that happens. So the first step, as I told you, is a blood vessel bursting in the brain. And that doesn't seem like it might not seem like that big of a deal, but the problem is that your brain cells are really, really sensitive to any kind of environmental change. And that can actually kill them. So I want to ask you in the chat here, do you guys know of any kind of cells that are in the brain that are really important to protect and that you really don't want to die? Neurons, yes. Neurons, 3 votes for neurons, 5 votes for neurons. Yes, you all agree it's neurons. Excellent. Okay, so you're absolutely right. If blood leaks into the brain from a burst blood vessel, that will kill neurons, leading to a lot of brain damage. Then after those neurons die, other brain cells detect that these neurons are dead, and they release chemicals into the blood that are danger signals that flow through your body and tell your immune system that we're under attack, right? I don't know what's going on, but there's dead neurons. Maybe there's an infection or something, but we need help. So those danger signals flow through the body and activate your immune system. And who do you think responds? It's the macrophages, right? So the macrophages then come into the brain, and in response to these danger signals, they become these activated killing machines. And they are ready to just kill any infection that's there, right? Bacteria, parasites, whatever, they're ready to kill. The problem is that when they get to the brain, they don't find any bacteria or parasites or anything to kill. They find some dead neurons and a lot of healthy neurons. And so what we found is that these activated macrophages, when they come into the brain after a stroke, actually cause more damage than good. So in the superhero analogy, this is kind of like a town that suffers from an earthquake, right? So after an earthquake, maybe the buildings fall down, some buildings catch on fire, maybe there are alarms going off, and from a distance, it might look like this town is under attack. And if the Hulk comes in thinking that the town is under attack from some villain, and he gets all angry and just starts Hulk smashing everything, trying to kill the villain that's caused this problem, that's not going to help at all, right? That will only make things worse. And this is kind of like what happens when macrophages come into the brain after a person has suffered a stroke. So in my research, I'm studying how can we calm these macrophages down after a stroke? How can we take these macrophages that have been activated by these danger signals that are produced after a stroke and turn them into non-activated macrophages so they don't make the brain damage even worse. But this is a really difficult question, right? Nobody knows the answer to this question. So how can we even, like, where would we even start answering it? Well, a common tool that scientists use is building on the research that other scientists have done in related fields. And other scientists have found that when macrophages are activated by bacteria during an infection, one way that they can calm themselves down and stop killing is by eating these dead cells that died during the infection. And so in my project, I'm studying what if that's also true during stroke? What if these macrophages that were activated by danger signals can eat dead cells, and then that will calm them down and turn them into a non-activated macrophage that will not cause so much brain damage. In other words, maybe eating dead cells is a way that we can calm down the Hulk. So in order to answer this question, I did an experiment. So I took blood from a blood donor, and I isolated white blood cells from it, and I activated these white blood cells with bacteria, and then I gave them dead cells to eat. And we know from the previous research that when you do this, this results in the macrophages becoming non-activated because they were activated by the bacteria, but then when they ate the dead cells, they became non-activated. But I want to know if this is also true during stroke. So I set up an additional experiment in which I activated macrophages with the danger signals that are produced in the brain during stroke, and then gave them dead cells to eat to see if by eating dead cells, that also calms down macrophages after stroke. And this is the question: do we get non-activated macrophages after all of this? And here are the results of that experiment. You can see on the vertical axis here, we have a measurement in the lab where we can measure how activated a macrophage is. So a low number is a macrophage that's not very activated, and a high number is a really activated macrophage. It's a killing machine. On the horizontal axis, you can see the different treatment groups. So these cells on the left were activated with bacteria in the presence of dead cells, and the cells on the right were activated with these danger signals that are produced after a stroke and then given dead cells to eat. And what you can see here is that when macrophages are activated with bacteria and then given dead cells to eat, the dead cells calm the macrophages back down, right? These macrophages are not activated. They essentially look like they were never activated at all. They're not killing machines anymore. However, you can see that when macrophages are activated by the danger signals that are produced during stroke, even if you give them these dead cells to eat, the macrophages don't turn off. They just keep killing. And this is important because this might explain why these macrophages are so damaging in the brain after a stroke. It's because even though there are some dead neurons around that these macrophages could eat, and you'd think that that would calm them down, this isn't enough to calm them down. So they just keep killing them. So this experiment has formed the foundation for my project in which I can answer additional questions about this problem. So I told you before that eating dead cells limits macrophage activation, at least during bacterial infection, but nobody knows why that is. So that's a question that I'm going to be answering. Also, I discovered that danger signals are really effective at activating macrophages in a way that they can't even really be suppressed, but we don't understand why that is, so we have to investigate that further. And most importantly, we need to figure out how we can limit macrophage activation during stroke so that we can limit the brain damage that happens. And we need to figure out how to take these really activated killing machine macrophages and turn them into the non-activated macrophages so they don't kill healthy neurons after stroke and make people even sicker than they were. So conclusions from this talk. 1, your blood contains immune cells, your white blood cells, that circulate through your body looking for any kind of infection, and they protect you from infection. And those are absolutely required for you to stay healthy. However, your immune system also needs to know when to stop fighting so that your immune cells don't hurt your own cells in the process of defending you from infection. And 3, your immune cells limit their activation in many different ways, and this depends on the situation in which they were activated. So an immune cell that was activated in response to bacteria in a cut will be suppressed in a different way than a macrophage that was activated after stroke. So with that, I would like to thank my lab. Everyone in this photo has helped me on my project, and I help them on all of their projects too, because just like superheroes, we can do much more as a team than we can individually. And I also thank all of you for listening to my talk, and I look forward to answering any questions you have. Thanks.
We'd like to thank you, John, for such an amazing talk. I will speak for the crowd and thank you personally. All right. Okay, Matt, I'm ready for you to pull back John and Will so we can hear them battle it out one last time to answer these questions.
Great, thanks, Deandra. And while Josie is filling out those or calculating all of those polls that you guys just took, let's ask our speaker a few questions. So the first question will be for Will. So the question is, how does race and ethnicity affect your research on public health? Have you noticed some viruses, disease, etc., be more popular and more likely to occur in some races and ethnicities over others?
Yeah, so thank you so much for the question. I hope my talk really explained well how race and ethnicity play such a significant role in the health of people by these social and historical factors that play a big role in people's backgrounds and experiences. So we as public health researchers really use race and ethnicity as a lens to understand the different experiences of different groups of people and the way they experience the world. So we do study a lot of diseases based upon categorizing people into different races and ethnicities. And that doesn't just go for Black or African American people or Hispanic people, but also non-Hispanic white people and Asian people as well. So we do see differences across races and ethnicities for a lot of different diseases, such as COVID-19, which I talked about today, which has Black and African American people and Hispanic or Latinx people experiencing COVID-19 more often. So hopefully that kind of answers that.
Great, yeah. All right, thanks. So for the next question, we'll go to John. And the question is, how do the neutrophils get drawn to the bacteria? Like, how does it know the bacteria is there?
Yeah, that's an excellent question. And actually, it's kind of cool because a researcher at Yale actually made this discovery in the in the early 1990s. He's Ruslan Mechitov and he still works here, so go Yale. But so when bacteria or any other kind of infectious germ in the body is going through the body, they are shedding little bits of them are kind of falling off, kind of like we shed skin. And your immune cells can detect those little bits. So in my little cartoons, the bacteria had tails. Those little tails little bits can come off, and the neutrophils can detect those. They have special receptors on the outside of the neutrophil. They can detect the tails of bacteria. They can detect parts of the shell of bacteria. They can detect all different parts. And and that helps them chase the bacteria down.
Okay, great. Thanks for that answer. All right, another question for Will. How did you resolve the factor of correlation versus causation in your survey research?
Yes, so because we were doing survey research, we actually could only draw correlations. So we can't actually say anything is causative in the type of survey research that I was doing. So everything I presented today was kind of showing you things that we see and things that we examine and giving us descriptive kind of information on the way different groups experience things and things are like the way things are occurring. So again, more so on the correlation side today when looking at survey research, whereas getting causation requires a couple of different mechanisms, which I wasn't able to talk about today.
All right, great, thanks. Another question for John, so kind of going on both themes of your talk. Will the neutrophil run out of energy like the Hulk?
That's the thing. It seems like no. You might expect that our cells after clearing an infection, your cells would just naturally kind of stop fighting, and to a certain extent that does happen. But you really need these active measures to stop the cells from fighting. So it's kind of like, you know, in these superhero movies, they show that Hulk, even after all the villains are gone, Hulk keeps smashing. It's actually a really good analogy because he has a hard time calming himself down, and other Avengers have to come in and help him calm down. And it's actually very similar to these macrophages. They don't just run out of energy. There's lots of ways that they calm themselves down, and other cells can come and help them calm down, but they usually need these active mechanisms to calm down.
Great. All right. One last quick question, which doesn't have to do with science, but someone was wondering, since you said your favorite superhero was Spider-Man, who is your least favorite superhero?
I don't know. I don't know, man. I don't really like superheroes.
All right.
Yeah. Sorry.
Well, that's okay. They're all pretty good. All right. With that, we'll turn it over to Josie, who will give the final results for today's battle.
All right. So thank you, everyone. Thanks to both our speakers. Thanks to everyone who shared their feedback with our speakers. I know that giving these talks, it's a lot of work put in, and it's great to kind of hear what went well, what they can work on for future talks. So I know everyone is really excited to hear the results of the voting. So before I do that, I need everyone at home to give me a drum roll. All right, I see some in the chat. All right. Are we ready? Okay. The first question we asked you all is, how understandable was the presentation? Okay, we asked you to rank 1 through 5, and you ranked William at a little bit above a 4.4, which is really quite high. Jonathan came in a little bit under that, but also a great score. Fantastic. Okay, so we have William a little bit ahead here. Question number 2, how much did this presentation spark your curiosity and imagination? All right. William came in here at like a 3.8. Maybe you don't have to imagine so much about COVID. I don't know. Maybe the superheroes got you here. Jonathan came in a little bit above 4. All right. These are awesome. All right. Question 3, how much more do you feel you know about this topic compared to before? This is a big point that we're trying to teach you guys something here, right? So William, you guys gave a 4. Awesome. Oh, like a 4.3 or something for Jonathan on this one. Amazing. All right. I'm seeing a lot of people cheering in the chat here. All right. So when we average this all together, for our total points, we get just over 4 for William and just over 4.2 for Jonathan. So very close, but the win goes to Jonathan for this one. So big congratulations. And thanks to both of you, great talks. As you can see, hopefully in the chat, they love both of them a lot. So absolutely amazing.